Hello, my name is Bahareh and I'm going to present a project that will look into whether dyslexic readers have problem in recognizing a specific object or process. Dyslexia is a problem in reading that occurs despite normal intellectual capacity, intact sensory abilities, and adequate educational opportunities. Dyslexia often described as a phonological deficit, which means difficulty in manipulating and distinguishing phonemes that are the smallest units of speech sound. Specific regions in area of brain that are important for recognizing objects tend to be underactive in dyslexic readers. This is consistent with some studies that shows that dyslexic readers have problem in recognizing faces and objects. In this study, we investigated whether dyslexic readers have problem with specific stimulus categories. Even if the problem of some dyslexic readers are visual, they could be restricted to visual word processing, or they could generalize to other visual objects, but they might not generalize to all visual objects, because there are some previous works that indicate that certain objects are special, especially faces that might have their own dedicated processing mechanism. So faces might be distinct from other visual categories. For example, there are people who after brain damage have very severe problem in recognizing faces, but not other visual objects. And there are also people who after brain damage have problem with recognizing words, but not problem with face recognition. We were also interested to see whether dyslexic readers have problem with featural or configural processing. The brain might not use one way to recognize objects visually. It might use many different methods that sometimes use them simultaneously. There are two ways that people might use to process objects, featural and configural. Visual features of word would be something like letters in the word. Just by changing one feature, we can change the identity of word. For example, here, by changing one feature, which is C, we change the identity of cat to be bat. For changing the configural processing, we change the distance between the features of object. But this does not necessarily change the identity of words. As you can see in the cat word, it seems that configural information are less likely to influence reading ability. But there are evidence showing that experts use more holistic or configural processing to read. In our task, we manipulated featural and configural information of faces and houses. For example, here we changed the feature of faces. You can see that these two images have different eyes, nose, and lips. And here we did the same for houses. Windows, doors are different between these two images. And here we change the configural information of faces. So features are the same, but we change the distance between them. For example, here you can see that the distance between nose and eyes are different between these two images. We did the same for house, and we changed the distance between windows and doors while the features were the same. In our task, there was a fixation. Then there was a sample, that it was face or house. Then a mask, and after that there was two images, that one of them was identical with the sample and another one was different featurally or configurally, and we asked participants to show us that which one is similar to the sample. By comparing the overall group difference, we found that dyslexic readers have problem in house recognition, but they were okay with face recognition. But something that surprised us was that they have problem in both featural and configural processing. What overall accuracy misses is that by relying solely on overall accuracy, the relations between different conditions will be overlooked. Here, for example, we have two conditions or scales, A and B. The darker colors means more correlated. If we only compare the overall accuracy of A between two groups, we will miss the relations between A and B. Two groups might be equally good at A condition, but use different strategies for doing that. If A and B tap into different skills that requires different strategies, and accuracy in trial of the task A should be more correlated to the accuracy in another trial of task A. Then the left pattern would be our conceptual models that assumes A and B are independent skills. If A and B are not independent that tap into the same skills, then A should not be more correlated with another trial of A than it is with another trial of B, and we would see the right pattern. How well these patterns correspond to the real data is what we are looking at in representational similarity analysis, where we compare conceptual models to reference models. Reference models are the correlation between featural and configural processing of faces and houses with different difficulty levels for dyslexic readers and typical readers. Please note that darker color means that they are more positively correlated. Here, for example, there is a low correlation between configural face and configural house. And here, there is a high correlation between featural face and configural face. These are the conceptual models for stimulus, process, and difficulty levels. If these patterns correspond to reference models, that means that they are independent skills. Here, for example, is the conceptual model of a stimulus. These two are both faces, so they are highly correlated. And here one is face and another one is house, so they are not correlated. It is the same for conceptual model of process. These are both featural, so they are correlated. And here one of them is featural and another one is configural, so they are not correlated. For typical readers, we found that the stimulus conceptual models corresponds to the real data. Some typical readers seems to be good at face recognition and some at house recognition, but they are not necessarily the same people. This shows that faces and house recognition are two separate skills for typical readers. We found the pattern of conceptual model of process in typical readers, which means that they act differently based on different process. We did not find the pattern of conceptual model of difficulty level in the real data of typical readers, and we did not expect to find this pattern because if a participant performed well on easy trials, then he or she might also perform comparatively well on more difficult trials. We also found this stimulus pattern for dyslexic readers. However, we did not find any indication that dyslexic readers act differently based on different process. We also did not find the difficulty level pattern in dyslexic readers' data. The representational similarity analysis showed that typical readers perform differently depending on both face and houses and featural versus configural processing. Dyslexic readers perform differently based on stimulus categories, but not process. It seems that dyslexic readers solely relied on one process when analyzing the stimuli. It is possible that if dyslexic readers cannot flexibly change the way that they process a stimuli depend on what it has been to be relevant, it affects their reading. As to read efficiently, both featural and configural processing are required. I would like to thank my supervisor, collaborators, and thank you for your attention.